Alright, welcome to this tutorial, which is the extension of the tutorial on the addition laws of vectors. In this tutorial, I'm going to demonstrate the addition law formula of parallelogram approach. So, if you remember from the previous lecture, it was said that the parallelogram law of addition of vectors can be used when two vectors like v1 and v2 share the same initial point or tails. So if this is vector v1 and this is vector v2, as you see, they have the shared initial points. So the resultant vector for their addition will be the diagonal of a parallelogram which starts from the joint point. So I am creating a parallelogram shape. Then I'm going to sketch the diagonal for this quadratic shape and I name it R, standing for resultant vector. The angle between these two vectors v1 and v2 is alpha, and I'm going to extend vector v2 to create a right triangle next to the parallelogram. Also, I'm going to name every point A, B, C, D, and E. Now, if you focus on this shape, you can see some triangles inside the parallelogram and the whole shape. I consider the biggest right triangle, which is A, C, and D. And also, I have the smaller right triangle, which is B, C, D. From geometry, I can write the Pythagorean theorem for ACD, which is the hypotenuse AD power 2 is equal to AC power 2 plus CD power 2. For the smaller right triangle BCD, I can write the theorem as the hypotenuse BD power 2 is equal to BC power 2 plus CD power 2. From geometry, you know, if the angle between AE and AB is alpha, the same angle exists here. So I can write the sine of alpha and cosine of alpha for the right triangle BCD. The sine of alpha is nothing but the opposite side CD over the hypotenuse BD, that can be written as CD is equal to BD times sine of alpha, and the cosine of alpha is nothing but the adjacent side BC over the hypotenuse BD, and it can be written in another way as BC is equal to BD times cosine of alpha. With all of these expressions in mind, I'm going to substitute some of them with the initial terms. So in the case of AD power 2 is equal to AC, which can be written as AB plus BC power 2 plus CD power 2. Also, I have substitutions for CD and BC. So I can rewrite this expression as AB plus BD times cosine of alpha power 2 plus CD power 2, which can be written as BD times sine of alpha power 2. So if I expand the brackets, I will have AB power 2 plus BD power 2 cosine power 2 alpha plus 2 BD times AB times cosine of alpha plus BD power 2 times sine power 2 alpha. So one of the most straightforward formulas in trigonometry is sine A power 2 plus cosine A power 2 is equal to 1. So with this in mind, I can say BD power 2 times cosine power 2 alpha and BD power 2 times sine power 2 alpha can follow the same logic. So I can write AB power 2 plus BD power 2 times sine power 2 alpha plus cosine power 2 alpha, which is 1 plus 2BD times AB times cosine of alpha. So now I can substitute the magnitude of vectors v1, v2 and their resultant vector r in the corresponding sides. So AD is nothing but r power 2 is equal to AB is v2 power 2 plus BD has the same length as AE, and AE is v1 power 2 plus 2BD is AE, which is V1, times AB is V2, times cosine of alpha, and finally the magnitude of R is nothing but the square root of V1 power 2 plus V2 power 2 plus 2 V1 times V2 times cosine of alpha. So this formula can be obtained through this geometric approach with help of trigonometry, and as you see, the formula is the same for both of triangle and parallelogram laws.